And we are back. So we only have two talks remaining in this really long conference. But not for that, they are less interesting topic. In fact, I am really interested about the next one because it's something that I believe is really essential for many developers. So I would like to invite to stage now to Gaurav. Hey, Gaurav,
Yeah. Hi.
how's it going?
Yeah, doing good.
Perfect. What time is it there?
It's 12:30 p.m.
Okay. So you're more than awake and ready to show us the cool things of your talk. I think that I have the slides here. I will not
Yes.
take some of your time, so maybe you can introduce yourself. Yeah. With that, the floor is yours.
Thank you. Okay, hello everyone. How's it going? And I hope everyone is going good. Okay, so let's start. Here is about myself. Once again, hello. My name is Gaurav. I am a high school student, and today I'm going to talk about doing some maths in Python. Yeah, in this talk, we are not solving like complex mathematical problems. Instead, we are just enjoying like what we can do with Python in mathematics, like graphs, some images, and some like integration differentiations, things like that. And I am interested in machine learning in Python, by the way, from since in my eighth grade. And yes, I work at Codeday India as the head of operations and finance. If you don't know about Codeday is a US-based nonprofit, which is basically at Codeday we get excited beginners about coding by organizing code days in different cities around the world. Okay, so let's get started. Mhm. Okay, so I have this Jupyter notebook in Colab. So I'm using Google Colab, and I recommend to use Google Colab to avoid any issues like installing libraries. Like I have an error right installing this, which is basemap. So I recommend to use Colab and end of the HC operations. All right. So let's start. Okay. I hope that font is visible to you and all good to go. So the first thing that we have to do is to installing the required libraries. So we need NumPy, Pandas, SymPy, which is the main man of the day, and base map, which is I'm using some like drawing some maps in Python, like we are plotting something into the map. So we need base maps and IPyWidgets that doing something with matplotlib graphs. So let me run this cell. NumPy Panda seems already interested already installed in Colab. So just going further. All right, so this is done. So firstly, I will tell you that which libraries we are using. So firstly, which is the main, which is SymPy. We are using SymPy, which is basically SymPy called for the symbolic mathematics, and it's like as written in its website that it aims to become a fully featured computer algebra system while keeping the code as simple as possible. So yes, I personally tried to the SymPy. Code is very small. Is like you can short the code. I will show you later. So here is a sample code from the SymPy. Like in this, there is a variable which is assigning to the symbol variable in of the SymPy, and we are just plotting an expression which is x. Okay. The second library we are using, which is matplotlib, which is generally, I think all of you know about generating graphs or drawing graphs in matplotlib. Next, we are using IPyWidgets, which is like a sort of addition to the Jupyter notebook when it's come to the creating widgets and like working with graphs more interactively. So here's the sample code. I will show you the demo what IPyWidgets do. Something like the drawer on the Jupyter notebook. And the fourth that we are using is called NumPy. So all of you maybe know NumPy. It is basically for the numerical computing in Python. So it's a Python library which is like mainly has a arrays and working with arrays. Here is a simple array. All right. So the Python standard library has already a math built-in module. So firstly, we'll explore that. Then we have a couple of more, like you can see in the sidebar, we have these types of things, which is a little bit of advanced topics. So here I'm importing the mathematics library, and here's a function called math.c. So let me run this, and here you can see that the variable which is assigned math to c is 7.9, which comes to 8. It's basically a round of the things, and 9.2 which becomes tens. In the math library or the built-in module in Python have something called math.py. So we'll try to find the area and the circumference of the circle. So here's the radius that was given to us, that was 3. So r is equals to 3, which is basically the radius, and the formula of the circumference is 2 pi r. So the formula became c equals to 2 math.pi, which is basically the pi in, which is 22.7 into R, and here's I'm printing the stuff. Secondly, there is another thing called area in circle, so which is math.pi into R, which pi r square is the formula of the area. That's why we are using 2 times R. Let me run this. And yeah, you can see that pi has a value of 3.14156, blah, blah, blah. And here's the circumference and the area. So this is very simple, I know. All right. Now it's time to do some factorials. So here's a block of code written in the core Python, like in the fresh Python, from this to this. But this is just one line of code that is math.factorial and the number which for which factorial you want to found. So you can see that how the math function is helpful. Instead of writing this, we can just pass this function to get the value. Alright. As I said that we are using the SymPy. Let me run this again. Okay, yeah. As I said that mainly we are using SymPy, so it's good to use learn some basics in just a couple of minutes. I will not recommend it, but like we are using SymPy, so it's better to have something. So firstly, here we are just importing the SymPy as SNP, and this is very important. Like just like in the Flask, we have app, run, debug, something like that. Same in the SymPy, we have symbols x, y, and z, which assigned to a symbols x, y, z. So SymPy is nothing but like it just created it's just used for creating like symbolic functions or symbolic things in the Python. So if I run this cell, mm, which is actually assigning x equals to x square. Oops, we have an error. Snp.goes. Okay, let me see. Immutable object has no attribution. The same. Okay, so what we can do, just remove this first of all. Let's print x. So it will print just like that. Mm, Why is not variable? Oh, I forgot to run this. 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 Now we have, and we need a y also. Just adding y, which is 2 into x, and then x plus y. Let's run this. Hopefully it is going to work. Let's see. Yes. So you can see the senpai is just like these fancy type of words. If you just say the print x, it will print something like that. Like you cannot play with this. But when it's like 3x to the power 4, you can actually do some cool things with the help of senpai. The next thing, which is called the factors. So here is a simple quadratic equation I have. Now I want to do a factor of this. So for a simple, we have a normal function which is called factor. So just give a variable quadratic equation, and it will pass out with the cool factor. Like you don't have to use pen and paper all around. Just use the Python, I would say. We have another, like in this we are squaring this factor. Like we are squaring a and b factor, which is again the nice answer. Alright. The next thing in the same pie that we have is called something solving equation. So x, which is I said that this is very important. Again, I'm using this at the x, which is x symbol x, and solving this equation, which is again a quadratic equation, and it will give me the answer which is nothing but n minus 1. Another thing in the algebraic expressions, like we are plotting something. So, for example, here we are just plotting the x sin x. In the SimPy has its own feature which is called plot, which is similar to the matplotlib, but it has different powers. Now here there's a little bit of advanced examples comes into the play. We have solving linear inequalities. So again, we are using SimPy, just importing a couple of things and get just importing a couple of things. And here's a main function that we are using to solve this complete linear equality. And here's the thing that here's the input that I given. You can use input in this. Let's try to run this. Cool. So yeah, it's something like linear inequalities in Python that you can use. And this is seriously very interesting to me, and hopefully you will also like it. Yep. So this is something I named it called Bus Life Fun. So it is something like that. Let me show you. It is something like that, which we have created using the math in Python. Like you can draw something like that. And this is the work of the iPad widget that we have installed earlier. So Baslifane, let me explain this the code block. So this is something like we are importing the libraries we required. We are using random just to like create random plots. By the way, it's created this type of image at when we got couple of like more points. Like if we get 10 points, like 4 to 4 points. Like if we get 0 points, it will create something like that. 0. If we get 6, 7, 7, it will create something like that. But if we create 3, 1, 4, 4, it looks like similar, very similar to the Baslic thing. So in this, we have just importing the libraries and we are creating a function which is shrunk from 1. Here's again some deep mathematical, not very basic calculations. We have another couple of more plots. Then we're getting the probability like Vitis plot or like random dot random. And then we are transforming this with like where to plot the plot. We are drawing the fun using the matplotlib or I think yeah, using a matplotlib and just like here minimum max, which is the slider basically, like minimum value is going to be 6, maximum value is going to be 10,000. Let me run this again. As you can see that here is a fun with the 10 points, but when I increase the stat to 10,1089, it will look something like that. When it decreases to 539, which is completely half of that, it looks not very good. This is something a cool things that you can do in Python, like mathematics. Another thing that we have is visualizing the earthquake data. Is the complete the CSV file that you can randomly download from the internet. In case I have this, let me see if I can show you. Yep. Okay. Here is the CSV file that I have. Uh, in this code, like, we are just importing the CSV and we are calling to like append, like we have something called empty list and we are adding something like row number 7. So according to this, the row number 7 is of latitude. We have the latitude is there and then we have longitude which is there and we have the magnitudes which is there, which is row number n2. Then we have time string which is row number n10. Then this is the base map that we are using to create this type of map in Python. So it's basically more about the visualizing and importing. Then again, we are using NumPy just to like do sort of things, like solving couple of things. Uh, Let me run this. Mhm. Wow, it is taking time. Okay. As soon as it's done, we'll okay. He's here. Come on, boy. It's almost done. Yeah. Okay, so it's going to be almost done. Yeah, we have successfully done. So here we can see that we can plot the globe with some data like that. So it's saying that earthquakes of the magnitude 1.0 or greater, 25 through 27. The next thing that we have is just called embedding animations in Matplotlib. Still, again, we are using math, some kind of math here, like you can see the cos theta and the sine theta. Again, we are using some trigonometric functions here to create this animation. And to create this animation, we're basically using icon display. Again, it is going to take some moment. Again, let me explain this code. So we are taking the G as a value of 9.8, and here are the intervals, the update position as soon as the animation is growing. Here we are creating the animation. Here you can see the cool animation that we have created. Okay. Next thing, which is again a bit basic, but I think it is kind of useful thing if you are into the scientific calculation. It's not very good, like very advanced scientific calculations, but yet it is a kind of scientific calculation. So we are doing a couple of things like in the Python, it is just a functions and the value of if is, which is very simple, but again very useful. For example, if you have to, um, which conversion would you like to do? For example, I would like to do the second one. Oops. Yeah. Enter distance in miles. I would like to say 124. And the distance is kilometers. It is like you can do in the paper and pen and paper, but also you can do in the calculator. And okay, now finally it's time to do some calculus that we all know, I think, because as I'm the class 11th, grade 11, so I know a couple of things in calculus. Again, I'm using SymPy to do these calculations because SymPy has inbuilt functions to do calculations or calculus. So firstly, let me zoom out this. We are starting with the limits. So here is a limit that we have. It is just calling the simpy function, which is simpy sine x by 2 plus sine simpy sine x. It is just the simpy basically like giving this a fancy type of image, or you can see the text that we have. And here is actually solving like sp.limit, which is smp.limit. We need the limit smp.sign, which is basically limit sign x upon half plus smp.sign, which is simpy dot sin x, and with respect to the x and the simpy. If I run this, we'll get 1. Yes, the limit is 1. Another example is of cos x. So simpy has a limit of simpy dot cos x, which is exactly that, minus 1 divided by x with respect to the x dot simpy dot o, which is 0. Let's talk about the derivatives that we have. So simpy also have something called differentiation or derivatives upon the x. So here simply we are just solving this. So calling the function simpy, which is SMP, short form, that we imported here. Simpy dot diff, which is the differentiation, 1 plus simpy dot sin x, which is the inside this function, as you can see the brackets, because we have square also, divided by 1 minus cos x, simpy dot cos x, and as this is the square, we'll put square here, and then we have calling with respect to the d upon dx. So adding x here, if I run this, it will solve this equation. So think about a time like how much time it took to solve this equation on a paper and how much time it's taking in this Jupyter notebook. It seems very, very easy. Then we have another thing in SymPy which is called integrations. So here I have an integration of 4sec 3x and 3x dx. So we are calling the simpy function simpy integrate 4 into simpy sec 3x into simpy tan 3x with respect to x. So it will solve it again. This is something that actually Python can do with the help of SymPy. And then we can just use the traditional methods of writing a long code. For example, I'll show you that in the math we have, yeah, by the traditional method, I'm saying that doing by this way or using this way. I think this way is going to be the more better way, and time saving and productive. Instead of writing this long amount of code, we have SymPy to do these simple calculations, or maybe more complex. Depends on you. Okay, we are at the integration. So if I run this x squared 4, 3 cos x, it will solve just in a 0 second. You can see. Okay, and next we have another integration, which is 2 upon under root 1 minus x square minus 1 upon x1 upon 4 to the dx. So SymPy, again we are calling the function to SymPy to integrate this, just writing the stuff that we have inside the braces, and this is the same stuff that we have with respect to the x, and it will solve this in a minute. Next, we have definite integrals. So here is another integral. Just calling this integrate SymPy dot exponent x SymPy dot under root SymPy dot 2 x plus 9, which is gonna this is simply this that we have in this. By the way, this is the markdown, not the image. Like you can see here, this is the markdown. And also we have sequence and a series of something like that in SymPy. So just assigning the new symbol to the n. Okay, we have something. We have another equation here. Just calling the SymPy to do this stuff. 6 upon 4 uh, to the power n that we don't know, and n comma 0 SymPy dot oo is do let's say giving command to the SymPy to do this. We have another thing which is called complicated expressions. I love that. So it is again the type of integration. I've run the cell. So it is basically another thing is a long form of code. Think about that. How much time it took to do this calculation manually or even in the calculator, and how much time it's going to take. Like 0 seconds to do this calculation in the Python. This is something that's very cool about SymPy. Most people still, and we can use this in the high level computing. Alright. We have another expression that we are going to integrate. This is a bit long, so I'll just run it. It is going to take time. Okay, we solve this. It just took 7 seconds to solve this equation. That's the power of SymPy. Um, Next, we have improper integrals. Again, we have 16 tan to the power minus 1 x upon 1 plus x squared dx. So we just integrate this to the tan x and 1 plus x, which is the denominator, with respect to x0. If we run this, we will get the value of 2 pi square. Next, we have dot products, which is simply the for dot products we are simply using numpy. So this is a array, this is the another array, and numpy has inbuilt, which is called np.cross. Oops, I think we have to use dot here. Well, so if I use dot, you can see 32. If I use cross here, it will use 32. So yeah, that's all about from my side. I hope you enjoyed the presentation. If you have any questions, just let me know. Thank you.
Thank you very much, Gaurav. I think the talk was really interesting, and of course, the fact that you mentioned that you were in high school is even more impressive. Just a quick question. I mean, you mentioned this, and I would like to know, like, does anyone else from your classmates also are using this to somehow help the way into getting math done, or is it something that you believe that you are one of the only ones?
In my school, I think I am the only one, but I have a couple of friends that they are using this.
And do you have any restriction at school that maybe I don't know some
No,
professor
no,
tell
no.
you
This is
like
like
don't
we
use it?
are doing for like fun things, like learning more about the Python and more about the Python libraries.
Okay, Okay, that's really really nice. I mean, if you are doing this thing at the moment, I am pretty sure that you will be even crazier stuff in a couple of years, something. So keep up the good work. And it was really really nice talk to, and really nice to have you around.
Yeah, thank you.
Okay,